Welcome to lecture number 30 of microcontroller 8051 series. In this lecture, we will discuss the stack in 8051. We will discuss push and pop instructions. Those are related to the stack. Now, what is stack? Actually, stack is an area of RAM which is used by programmer and CPU. Programmer can use it to store some registers temporarily, and CPU can use it to store the addresses. Now we'll discuss how CPU uses and how programmer will use it. First of all, in 8051, there is one important SFR known as stack pointer. This is that stack pointer. This SFR is actually pointing to the stack area. Now, by default, I can say that this is the stack area. Because when you reset the microcontroller 8051, SP stack pointer will have address 07. Okay, 07H. So by default, stack pointer is pointing to this location 07H of the RAM. So it means that we can use the stack 07 onwards, that is 08, 09, 0A and so on. Okay. Now we can use this location for temporary storage. Suppose there is some data in accumulator, for example. This is an accumulator here, right? E0. This is the accumulator. Suppose there is some data and I want that data to be temporarily stored somewhere, because I want to free the accumulator for other purpose. But I want whatever the data in accumulator initially, that I will need later on. So the best way of doing this, I should push the contents of accumulator into stack area. Now where to push? Who will help it? Yes, stack pointer will help me. It will tell me where to store, in which location, at which address I can store the contents of accumulator, right? Once I will, for that, suppose I will say push the contents of accumulator into stack. Suppose it is stored here somewhere, for example, and stack pointer will point that location later on. We'll discuss the exact process. And once, suppose I will use the accumulator for other purpose, later on I will need the original contents back into accumulator. So I will use the instruction like pop. So pop accumulator will take, what it will do, it will take those content back into accumulator from stack area. So in this way, push is used for pushing the contents of some registers into stack area, and pop is used to take it back from stack area to that register, right? And in this process, SFR stack pointer is very useful, and this is the default area. Actually, we can change the stack location by changing SP, but by default it starts from 08. Actually, SP points 07, so you can use stack locations from 08, 09 like this. Okay, when you go on pushing, you can use 08, 09 like this, and when you go on popping, it will go on decrementing like that. In some microprocessors like 8085, 8086, the stack is used in different way. We can have like stack starts from higher location, and when we push, stack pointer decrements, and when we pop, stack pointer increments. But in 8051, when we push, stack pointer actually increments, and when we pop, then it decrements. Actually, we can compare stack with like a stack of books or stack of plates. Suppose I have this rack, okay, and in this rack I want to put the books. I assume that somebody knows the rack number. For example, this stack pointer is that who knows the rack number. By default, it is showing 07. So it is showing that don't use this location. You can start using location 8, 9 and onwards. So suppose I have first book of maths. I will say push maths. So maths book will come here. Okay. When I say another book, suppose I have physics book, I will say push physics, so physics books will come here. So stack pointer will later show 09. And when I say pop physics, physics book will come out of the stack. Okay, so in this way, whatever is pushed last, that will come out when you pop it, right? And stack pointer will keep track at which location the stack is currently working, right? This same concept you will find in data structure, maybe data structure using C or data structure using Java, where you will find stack and queues. Actually, all these concepts have their origin from this assembly language or microcontrollers, right? Anyway, now we'll go to one more slide where we'll discuss about the push instruction. Okay. So I already discussed that push is the way we can use the stack memory for temporary storage, right? Suppose I have one instruction here, push accumulator. Okay. So as discussed in I have discussed, this is used to push the contents of accumulator into stack memory. Okay. But the important thing that is to be noted here is that we cannot use you can say names like A, R1, R2, R3, etc. We need to use the direct address only. So only direct addressing is supported here. Okay. So you cannot write push A, you need to write push 0E0. Now you will ask what is 0E0? Actually 0E0 is what? The address of accumulator. Accumulator is an important SFR and its address in the memory is actually E0. So you cannot write push A. The only way you have to write is push 0E0. Similarly, suppose you want to push the contents of R3 into stack memory, you cannot write push R3, you need to write push 03. So here you can see 03 is what the address of R3. Suppose you want to push R7, so you will write push 07 like that. Okay, now we'll assume some initial conditions. Suppose I have stack pointer pointing 07 initially by default. Suppose CPU is reset and stack pointer is pointing 07. Okay. Now let us assume the contents of accumulator is 12 and contents of R3 is 9B hexadecimal numbers. Okay. And suppose I give the instruction push 0E0. What will happen? See, SP will increment by 1. So SP is showing 07, but it will increment. So it will show 08. And at this location, contents of accumulator will be stored. Now you will ask why we need to store the contents of accumulator here. Because we want to free the accumulator for some purpose. Later on, we can pop it from stack and we can get it back. Okay. So in this way, at this moment, when you say you write this instruction push 0E0, SP will become 08 and contents of accumulator will be stored at location 08. Now suppose again we write an instruction push 03. So what will happen? Again SP will increment. So SP will become 09 and at the 09th location, contents of R3 will be stored. Okay. So in this way, when you go on pushing, what happens? SP will increment and at that location, which is pointed by SP, the contents of the direct memory address which you have written in the push instruction will be stored. In this way, you can use the push instruction for pushing. But important thing to be noted is, it is allowing only direct addressing mode. Okay, register addressing mode or indirect or other addressing modes are unfortunately not allowed. We can write only direct addresses. Suppose you want to push B. So how will you do? You will write push 0F0. So you should know about this programming model of 8051. Now where will be your program? Your program will be here. Your instructions will be here in internal ROM. Okay. And whatever instruction I am discussing, those will be here. Okay. But stack will be here, the RAM area, and the pointer stack pointer is here. That is your SFR. Okay, so you got the push instruction. Now we'll discuss about one more instruction, that is a pop instruction. Very reverse. What we do in the push? We push the contents of some register into stack memory. Now pop will do the exactly reverse. The contents from whatever the contents pushed will take back from stack memory into specific register. Now let us take one example. Suppose we want to pop into accumulator or pop into R3. But note that how we can write in a direct address way only. Okay, pop 03 or pop 0E0, what we discuss, because accumulator's address is E0 and R3 is 03. Now we start from initial condition. Suppose stack pointer is showing 09. So this is your stack pointer and it is showing the address 09 here. Okay. The stack pointer is pointing to this address 09. Now you write an instruction pop 03. What will happen? Whatever is pointed by stack pointer, that location has some contents and those contents will be popped into 03. Now what is 03? 03 is R3. So whatever is the contents will come into which register? R3 register, and stack pointer will decrement. So stack pointer will become how much? It was 09 initially. Now it will become 08. Okay, so stack pointer will point to this location because you have popped from top of the stack. Now it will decrement. It will show 08. Now suppose you again write an instruction like pop 0E0 here. What will happen? Now stack pointer is pointing this location, and from this location whatever is the contents will come into E0, that is your accumulator, right? And stack pointer will again decrement. Now it will start showing 07. So it will start showing this location. In this way, when you pop, what happens? Whatever is the stack pointer is pointing, from that location contents are copied to the direct address whatever is mentioned in your instruction, and stack pointer decrements. In this way the pop instruction executes. Now we'll discuss one more important point about the stack, is that as with microcontroller also use the stack for its own purpose. See, push, pop instructions we discussed. Those instructions programmer is using for temporary storage, right? But microcontroller also use the stack. When it use the stack, for that we need to discuss some concept about the subroutine. Now we'll come in next lectures in detail about the subroutine. For now, let us assume that there is some separate code called as a subroutine, and this is your main program suppose, and you need to execute the subroutine which is written at some another location of memory. How you execute that? You will use the instruction LCALL. LCALL, suppose label subroutine 1. So when this instruction is executed, microcontrollers will shift to this area, will execute the code here, and when the return is there, it will come back to the next instruction about the after the LCALL. Okay. So when microcontroller want to go to the subroutine, it should store the return address. Return address is what? See, when this LCALL is going to execute, program counter will be showing the address of this instruction to be executed next. So by default, program counters is showing 0035. Suppose 0035 is the address of this instruction. See, this instruction is stored in what? Code memory. So there is some code. That code is available from suppose location 0035. Now when you want to execute the subroutine, program counter should point to the address of subroutine, that is 0082. For example, so subroutine 1 is suppose written at 0082. So program counter should now change to this address, so that execution will start from this area. But there is return as well, right? So when return will execute, what should happen? Program counter should come back to the main code, that is program counter should show 0035 again. So execution will start from this instruction onwards. So this is handled using a stack memory. Let us assume when LCALL is going to execute, program counter's content is 0035, which is the address of this instruction. That will be pushed into stack memory. Suppose stack pointer is showing 08. Okay, so these 2 bytes will be pushed at suppose 09 and 0A, where lower byte is suppose at lower memory, higher byte is suppose at higher memory. Okay, so stack pointer will now start pointing to 0A. Okay, and you will, our program counter will modify to 00A2, so execution will start from the subroutine area. Now these instructions will execute. Now when the return is to be executed, what will happen? It should return back in the main program from where it went to the subroutine. So this should be the next address that should be in the program counter. So what will happen? So it is in that case, whatever the bytes pushed into stack memory will be popped back into program counter. So we can say that 0035, these 2 bytes will come back to the program counter and stack pointer will again become 08, and as program counter shows 0035, what will happen? Execution will start from the move whatever the instruction that is written next to the LCALL. So in this way, microcontroller also use the stack to store the return addresses when subroutine is to be executed. But programmer should take care that in subroutine, the number of push and number of pop should be matching. Otherwise, what will happen? If that makes some differences, in that case, return address will not be proper. So, if suppose in subroutine programmer write 5 push instruction, then 5 pop instruction should also be there. Okay. So, and in that case only, stack pointer will show the proper address when return is to be executed, and microcontroller will return back at the proper location. So this is how we can say that a stack is very useful area of memory which is shared by microcontroller and programmer should take care. Thanks for watching.